Assalamu alaikum warahmatullah, dear students. I'm writing the organic chemistry notes for you. This video will be uploaded on the YouTube. Actually, I was recording that video, but unfortunately the sound was not recorded. So I'm remaking this video for you people once again, and I hope this will be useful to you. So first of all, we'll be dealing with hydrocarbons. What are hydrocarbons? These are the compounds of carbon and hydrogen only. What are the two classifications of hydrocarbon? Hydrocarbons are classified into two categories: saturated hydrocarbons and unsaturated hydrocarbons. Saturated hydrocarbons. These hydrocarbons are having a carbon-carbon single bond in between them. Their example is alkanes. Unsaturated hydrocarbons. These hydrocarbons are having at least one carbon-to-carbon double bond or one carbon-to-carbon triple bond. Their examples are alkenes having double bonds and alkynes having triple bonds. This is alkyne, okay? Not alkynes. Alkynes. What is a homologous series? It's the group of compounds which are having the following properties. They all have the same general formula, chemical properties, functional group, but their physical properties are depending on the number of carbon atoms in the chain. Examples are alkanes, alkenes, alcohols, carboxylic acids, aldehydes, ketones, esters, amides, amides, halogenoalkanes. Halogenoalkanes. Okay. So these are the examples of the homologous series actually, okay. What is a functional group? A functional group is a bond, an atom, a group of atoms which are giving specific properties to the homologous series. Okay, so the examples which I was giving to you, I'll just open this now and I'll give you the example for it. Okay, for those functional groups which I'm going to talk to you about, let me redraw them once again. Functional groups. So first of all is alkane. Alkane is a functional group. Okay, alkane. Carbon carbon single bond is there. We have alkene. Carbon carbon double bond is there. Okay, we have alcohol. We represent it with NOH. Okay, this is a functional group of alcohol. We have an aldehyde. Aldehyde. Aldehyde, we have a functional group for aldehyde to be double bond O and then H. This is the aldehyde group. Okay, then we have C double bond O and then C. This is a ketone group. This is ketone. We have C double bond, single bond C, NOH. This is carboxylic acid. And we have an ester group, which is C with O and C. This is an ester group. Okay, and if I move on to from the ester group, this is now C and C double bond O with an N connected to C. This is an amide group. Okay, these are all functional groups and homologous series also. Okay, so they're giving specific properties, and one still is left there. Let me write that: halogenoalkanes. C with C and C, and you find one halogen connected to it. So this is the halogenoalkane. Okay, are we clear with this part? Okay, now after this, nomenclature, how to name the hydrocarbons. Okay, so nomenclature, naming hydrocarbons. Select the longest chain of carbon-carbon. Give it a numbering. Start the numbering from the side, which is giving least value to the functional group. Write down the name as following. Now see this rule. I'm going to talk about this rule now. First of all, selection of the longest chain. Let's suppose we have a compound with us, carbon and carbon and carbon and carbon. So selection of the longest chain, this is Cl is there. So I'm going to select the longest chain. This is the longest chain. Okay, this was point number one, done. Now I'm going to do the counting. I'll start counting 1, 2, 3 and 4 and 1, 2, 3 and 4. Now I'm going to choose the position of this Cl where it is getting the least value from left to right or from right to left. So I think from left to right the position is 2. So how do I get the name? First of all, the longest chain, what is the name of this? This is butane because 4 carbons are there. Okay, and 4 carbons are having a single bond, that's why it's butane. And chlorine is position 2, so we write 2 chlorobutane. Okay, now let me check another one. Let's suppose the chloro is on another position. It's on position number 1. So first of all, numbering, longest chain, this is the longest chain. 1 2 3 4, 1 2 3 4. You can count either from 1 2 3 and 4. So the least value is 1. Okay, so I'll call this to be 1 chlorobutane. Okay, the longest chain is butane. Okay, now 1 chloro and 2 chlorobutane, they are having the same molecular formula, and the molecular formula is C4H9Cl. That's the molecular formula, but their structure is different. So such compounds which are having same molecular formula but different structural formula are called isomers. Okay, define isomers. Isomers are different compounds having the same molecular formula but different structural or displayed formula. I'll give you a certain example of the isomers. Let's see some of the examples of the isomers now. And okay, so now I'm going to draw certain isomers for you. Okay, an example is of the alcohol, which I've already given to you in the class also. 1 2 and 3. There's an OH connected here, the rest are all hydrogen. 1 2 3 4 5 and 6 7. So the molecular formula is C3H7OH. Okay, and you can see it's on position number 1. If I'm doing the counting, I'll start counting 1 2 and 3. So it is called propane 1 whole. Okay, now if I'm writing another one, which is the isomer of this propane, okay, the OH is exactly here. So I'm going to note down 1 2 3 4 5 6 7 of the hydrogens are there. So it is also having the same C3H7 OH formula. Molecular formula is the same, you can see here, and it is called propane 2 whole. Okay, so these two are actually the isomers of each other. Isomers, because they have the same molecular formula, but you can see their structural formula is different from each other.